just a quick summary on this particular section, which is about the vector field and scalar field. So far you have now know the gradient, which is this one. This is gradient, nabla, and we have the divergent and curl. Okay, so by now we know that the gradient operator or nabla acts only on a scalar field, which then will give you a vector field if you have only nabla here. But if you have nabla dot, so we call that process, if just nabla dot, so it's nothing because this is just operator. So we call this nabla dot as a divergent operator. So you have to this one to be paired should be paired with vector field. Okay, so the outcome should be a scalar field, or the result should be a scalar field. Similarly, you have the nabla cross. So nabla cross is called a curl operator and should be paired with the vector field. So you have nabla cross, or we call this as a grad cross f. So the outcome is a vector field. So if you have the gradient of f, so it is sometimes they can give you the grad f. So this one is actually similar as the nabla f. And what is actually happened? So you have to find the partial derivatives f respect to x, y, and z, and the answer here should be a vector form. Okay, and similarly, if divergent f, so you have the grad dot f's. So you have the fx as well, just like this one, just like over here, but in this case, you don't have the vector ij key. It's just summation of all the components. Okay, it looks very similar, so you have to be careful. And the curl f, you have the nabla cross or grad cross f. So the process here is similar as you obtain the cross product between two vectors, and the outcome should be a vector. Okay, so the extension of the divergent and curl, the thing that we can also should know is there is a multiple operation, the combination of the gradient, divergent, and curl. Okay, in this case, let we define the small f is a scalar field or scalar function, and the capital F is a vector field or vector function. So if you have this, so this one is inward, we have div grad f, which means that divergent of the gradient of f. So in symbol, mathematical symbol, so you have the gradient f, which means the grad f, right? And the outcome here is a vector, isn't it? So when you have a vector, and this one also vector operator, and you have dot, so the answer should be a scalar. Okay, I think I should move this into here, so that easy for me to just jot down anything. Just a second. Okay, so for this one, the outcome here is a vector. So this is vector dot vector, and the outcome is scalar form, scalar function. How about this one? You have the curl of the gradient of f. So we solve for the gradient f, which means that this one. So this will give you vector, and vector cross vector, the answer is vector. So this is called multiple operation. So multiple mean multi operation. You have first gradient of, and the result here you have to apply the divergent. So now the third one, the gradient of divergent of vector field. So we solve for the divergent of vector field here, which means the formula will give you grad dot, right? The grad dot of the vector field will give you a scalar function. Now the gradient of the scalar function will give you a vector. Okay, and then similarly the fourth, divergent of the curl of f. So the curl of f is a vector, right? This one, what is the formula? So grad cross. So this is vector. So gradient, divergence. Okay, now we have divergence, which means that grad dot all of whatever inside the bracket. So grad dot vector, the answer should be scalar form. And here the fifth, curl of the curl of f. So we know that the curl f is vector, and the curl of the new vector form, for example, you have a vector g, and the outcome should be a vector. Okay, so meaning that in exam, I'm talking about the exam sake, what is actually the question which are related to this one? So they will give you a scalar field and a scalar and a vector field function. So now based on whatever the multiple operation that they give, then you have to do the calculation. Okay, so there are some interesting results based on the multiple operation. So when we have the curl of the gradient f, okay, this one you have to memorize, but if you don't, it's okay if you don't memorize, you have to just compute manually. But if you remember all these things, then you can just directly get the answer 0. Okay, because we understand that. But if with the condition that you remember all these things, but if you don't remember, then you just calculate manually. So we know that what is this? So curl of gradient f. So gradient f is grad f, and this one will give you vector. Okay, will give you a vector, and the gradient of this vector will give you 0. This applicable for any f that you have. Only this one. Okay, only this multiple operation. And then similarly, if you have the divergence of the curl of f, so the curl of f will give you a new vector. Let's see, you will get a vector g. So the divergence of the vector g will give you 0. So this is also applicable for any vector field. No condition. As long as you remember all this for this particular, only this particular multiple operation. Okay. And the third one, we have the divergence of the gradient of f. So we know that the gradient f will give you a vector. So you will get a vector, for example, vector g. And then the divergence of the vector g will give you, this one is actually scalar form, scalar function. And the special of this is actually, if you have the nabla dot nabla of the vector field, the scalar field, and the answer here will give you scalar, which means that you can see that the second derivatives of the scalar field, right? So for this part, it belongs to x, so f of x plus f of y plus f z z. So actually, this one is common. Okay, this equation or this operator. So this operator, this special operator here, where we'll give you this one, f of x plus f of y plus f of z. So this is called as a Laplacian operator, which means that you can rewrite this to be grad square f, which means that you have to put the second derivatives for each component. FZZ. Okay, so grad square f. So grad square here, grad square is called Laplacian operator because this one will give you Laplace equation. Okay, so if this one equal to 0, so this one, if you have only this one without equal, so this is called Laplacian operator. No, I mean this is the result. Okay, this is the result of the divergence of gradient f. But as you can see there, this one, if you factorize the f, so it looks like you have del square del x square plus del square del y square plus del square over del z square and multiplied by f. So what I want to say is this one in the bracket is actually nabla square or gradient square. So that is called Laplacian operator. Okay, so this is called Laplacian operator. But if your grad square f here is equal to 0, but if let's say your summation here is equal to 0, so we call this, there is a name for this special equation. So when there is the equal sign, meaning that you can call that as an equation. Okay, so if this one equal to 0, so we call that as a Laplace equation. And the function f here satisfy such equation, will give you, I mean, if you have the Laplace equation, so we can say that the function f is a harmonic function. It just introduce you, maybe in future you can see the Laplace equation. So now then maybe you can relate with this vector field, I mean the multiple operation. But you have there are many words regarding the related to the Laplace. Laplace is actually the name of the people. You have Laplace transform, and you have a Laplace equation, and so on. But Laplace transform nothing to do with Laplace equation. Okay, Laplace equation is coming from the Laplacian operator, where this one equal to 0, and that vector function, this function. If this function satisfy this equation, which means that if you put the derivatives for each component and when you total up and the answer is 0, so meaning that this function is a harmonic function. Okay. Okay, so as you can see here, I want to explain here. So this one, you have this, right? So this is from the above here, where it can give you this one is equal to grad square. Okay, or you can also have this. Okay, grad dot grad, because we know that the gradient and the gradient, they are vectors, so that's why we can combine them in this way. And where the answer here, you have the Laplacian operator, right? But this what we call that, this expression is not actually similar as this, because you have to be bear in mind that this is vector and this is vector. In order for you to have the correct operation, so this one should be where the dot or cross. But in this case, it's just normal multiple, just like the multiplication, normal multiplication, just like you have 2 multiplied by 3, but 2 and 3, this is not vector, it's just a scalar function. But this one in vector and vector, then you cannot multiply as normal way, whether you have to put dot or cross, just like this. So you have to bear in mind. Okay, so this is about the multiple operation. So next I will give you some example. Okay, maybe example 22. So you are given the scalar field or scalar function and the vector function. So you have 2 vector function here, f and g. So now you can see there are 3 questions. So you have to find the divergence of f, where the answer here is a scalar, right? And then when scalar, you have to multiply with scalar. So the answer should be scalar or vector? Should be a scalar. Okay, so that is our expectation. So actually, this is not the answer that we are looking for. You have to find the scalar expression, but before you proceed to do the calculation, you have to quick expectation, right? So okay, what is the outcome? What is the outcome or output of your calculation? Okay, so now you know that your final solution should be in scalar form, no IJK. And similarly, the second one, divergent Okay, the divergent will give you an expression, right? I mean a scalar and multiplied by the vector. So this one okay, right? Mathematically correct, because when you have a when there is a multiplication, so I mean this is okay if you have the multiplication between the scalar and vector, but for vector and vector you must have either dot or cross. So the answer there is should be vector. And the third one, so grad cross f will give you a vector, right? Okay, so inside here we give you a new vector, and the vector then multiplied by the scalar, and the outcome still a vector function. Okay, so next we want to compute what is the specific scalar and vector form that we have to obtain.